Great. Welcome everybody. This is the first session of day 2 of Ski Test Report. Thanks for coming out to see Ben talk about mocking people and other objects you might have in your database. And I just want to thank the sponsors again that we have. Without them, none of this would really be possible. Desert Digital Media, Xmission, Qualtrics, Automatic, and there's 2 more, and I can't remember. But anyways, please give a round of applause to Ben.
Actually, since this is being recorded, I'll use the microphone just so that I pick up on the recording. And because it's a smaller crowd, I'll tend not to shout as much. It's just a weird habit of mine. Getting started though, I do have the slides already available, so if it's something that you want to go ahead and, if you're having trouble seeing the screen up here or something's washed out, you can go ahead and download those and take a look at them. It's at my unique little URL there, bram.c /skiphp-mockery. So as you probably overheard me talking with this gentleman just a few minutes ago, I'm from Nashville. I'm a software architect for a company called Shootproof, which is based in Atlanta, Georgia. And we are a software as a service platform for professional photographers. We help them manage their studios, and we help them sell prints directly to clients. So they give me the awesome opportunity to get to come speak at conferences like this. So I enjoy working there, and I enjoy the team we have. I've been around the PHP community for a few years. In fact, this is probably my 103rd presentation I've given. I am keeping count because I'm egotistical like that. I'm a co-author along with Davey Shafik, who's here this week, of PHP Architect's Zen PHP Certification Study Guide, out in its 3rd edition now. Davey helped put that out last year, so it's a really good resource. I encourage you to pick it up, even if you don't plan on taking the certification. I founded the Atlanta PHP user group way back in 2004, and I'm currently a co-organizer at the Nashville PHP user group. So if user groups are something that you're interested in talking about, I'm definitely available to talk about those afterwards. I contributed a rate column to the PHP core, a little tiny feat, but I'm proud of that. And then I'm also a maintainer of the Ramsey UID library and the PHP League of Extraordinary Packages OAuth 2 client. Say that like 10 times fast. This is the gratuitous we're hiring slide. I would be remiss if I didn't mention my company. Again, they let me come out to things like this, and we have a great team. And if photography is something you're interested in, and you like programming in PHP or JavaScript, and you might think Atlanta sounds interesting, then we might be a good fit for you. So let me know. All right, introduction to mocking. So what is mocking? You're seeing like this bird up here. This is not a blue jay or a cardinal. This is a mockingbird. And we're not really talking about pointing at people and mocking them for the horrible code they've written. That's not what this is about. Mocking is a way to inject a test double into your test. It's a form of test double. And a test double is any kind of pretend object that's used in place of a real object for testing purposes. They differ from other test doubles. So you may have heard of things called stubs, for example, and that they're programmed with expectations about the calls that they're supposed to receive. So you tell a mock object, I expect you to receive this call, maybe with these parameters, this many times, and the mock object responds accordingly. Mocks are used in unit tests to replace a behavior of an object, or a service, for example, that are external to the current unit being tested. So when you test a unit, you don't want it to make all these calls to the database. You don't want it to call an external service. You really only want to test the code that's in that unit. And when I say unit, I mean like the code within a method on a class, right? That's an individual unit. And you really only want to test its code and not the side effects and behaviors that might generate as a result of running that code. So a mock object is a way of injecting a test double into that unit so that when it calls that test double, it just does what the test double expects it to do, and you don't call some external service, for example. Now I'm talking about Mockery in this talk, but why not PHP Unit? Because PHP Unit, how many have used PHP Unit? Okay. If you've used PHP Unit, you've probably used the mocking framework that PHP Unit already provides. And it's good. I mean, it's just as good as Mockery in a lot of ways, but it's also very verbose. And Mockery provides probably a better user experience with a lot more succinct API in order to create and use mock objects. You can use them together with PHP Unit mock objects. You can also use Mockery and a variety of other testing frameworks, so you're not stuck with PHP Unit if you want to use something else. Like there's Tune, which is another very popular PHP unit testing framework. There's PHP Spec and so forth. Mockery can be used with all of these. Also, Mockery provides abilities to mock things that PHP Unit can't do. Some of these are things like mocking static methods and mocking hard dependencies, which we'll talk about later in this presentation. Though those are topics of debate, I'll just show you how to do them. All right, so let's get started with Mockery. The first thing, obviously, is let's just use Composer to include it. If you're not using Composer, I would encourage you to check that out and try to see how you can fit it into your project. There are a lot of ways you can use it, maybe with a legacy project. We use it with a legacy project. It's fairly simple to do, but I'm showing you the command to install Mockery plus PHP Unit because I'm kind of assuming the use of PHP Unit in all of my examples, even though you don't have to use PHP Unit. Also, I will point out that when illustrating any kind of unit testing or testing techniques, it's incredibly difficult to come up with really good code examples that illustrate these concepts without being just too contrived. So a lot of the examples will be contrived that I'll show. If something just isn't quite clicking in your head on a concept, then feel free to ask. I'll try to elaborate as best I can. This is an example. This one in particular does come out of the Mockery examples in their documentation. This is a temperature class. And so the idea that we want to do is we want to test this class. We've got two methods on it, a constructor and an average. We want to test the average unit. This is the unit we want to test, the average method. And as you can see, what's happening here is that when we instantiate a temperature object, we pass it a service. Maybe this is a service that calls out to some weather service, right? Maybe it calls out to like the Weather Channel API or Weather Underground's API. It could call out to anything. In fact, we can inject multiple types of services depending on each instantiation so that one calls one service and another calls another. So we've made it flexible in doing that. In the average method, we're going to loop 3 times, call that service 3 times, read a temperature 3 times, add it all up, that's what this total plus equals is doing, and then we're going to divide by 3, and that's going to give us an average of 3 temperatures. So when we test this, we want to test that we get an average of 3 different temperatures. That's what our test will do. This is what the service class might look like. I'm just providing just an empty class here for the sake of example. It does something. It calls an external service. It calls a database of sorts. But it's not important what it does. What's important is it does something that we probably don't want it to do when we're running a test. This is how we might use it in a real-world scenario. The service, we might give it some parameters, like maybe there's an API key or something that you need to pass into it to communicate with that service. We pass it into our temperature object, and then we can echo the average. So what might a test look like? All right, so I'm showing several things here that are important to keep in mind. The first thing is, obviously, this is a PHP Unit test. So we're going to use PHP Unit as the test runner in this example. The first thing you see here is not important to testing the temperature object, but it is important for Mockery, and that's this teardown method. And at the end of each test run, Mockery needs to clean up after itself. And this might not be important for this particular example, but later we'll talk about how you might need to run some tests in isolation. And when you run a test in isolation, Mockery has to clean up after itself so that some of the objects or the classes it creates in memory don't stick around for the next test that gets run. So that's why you need the teardown method here. So that's a critical part of Mockery. The next thing is our test. This is test gets average temperature. So we're going to create a service mock. And in this case, I'm creating a service mock with the name service mock. This name means absolutely nothing to the test that I'm running. This is not a class name, it's just a string. In fact, it would just be easy for me to leave it blank, and I'd have an unnamed mock, and I'll show an unnamed mock later. But in this case, I'm just naming it service mock. This service mock should have a method on it called readTemp that should be called 3 times exactly, and each time it will return one of these values. The first time it's called, it will return 10. The second time it's called, it will return 12. And the third time it's called, it will return 14. And that's just how this mock is going to work as we call it. We're going to pass that into our temperature object, and then we're going to run the average method on the temperature object. Now, these are known values, these 3 values. We know that when we add them together and then divide them by 3, we get 12. So we're asserting that the average is going to be 12. It's a known response that we have. And that's important because in a test, you want to test known values, really. You know what this is going to return. And so all this is doing is testing that the code within the average method is running properly and doing the math that it should be doing properly. There's another important concept here, and that is that a mock object is something that you're really using to pass in to another object that you're testing. It's mocking up things that that object's depending on, so that you're not actually using the real service object. So some review real quick on the basics here. A mock replaces an object that is expected to make certain calls, and we set those expectations on the mock object. Service mock creates a Mockery mock object and is the loosest form of mock object. I mentioned this is just a named mock object. That's not a class name, that's just a string we gave it to name it. The object it returns is of this type, Mockery mock. And then I mentioned the teardown method. That's important to use, to include. You can put it in like a base test case that all your other test cases extend from too, so it's easy to do that. Any questions about these before I move on to some of the more deeper things? All right, so let's talk about some mock object basics. The first one is this. This is an unnamed mock. I mentioned this earlier. Service mock was a named mock. This is unnamed. So instead, we're just giving it an array. And this is another really loose form of mocking. We're just creating an object that's expecting calls to these methods. And here I'm just showing that, just for the sake of example, that when we call mock foo, we get back 1. And when we call mock bar, we get back 2. Because we've set up these key value pairs. And the key is the method to call, and the value in that array is the value to return when you call that method on the mock object. The downside to this, and with the earlier method, the named mock, is that we can't use it for anything that requires type hinting, because this doesn't set up a type on this mock object. It's just a generic mock object. Well, what if our temperature class looked like this? It's the same as what we saw earlier. There's just one simple change, and that is in the constructor on type hinting that there's a class of type service that should be passed in. Maybe it's an interface, maybe it's an abstract class, but we are type hinting here. Well, we can create typed mocks with class names. So here, what if I had a class that's Ramsey talks service, and that is the class that we're expecting to pass into the temperature object? Well, when I create my mock, I give it the fully qualified class name. So if you're using PHP 5.3 namespaces, you're going to have to pass it in like this. If you're using an older style, you can use underscores and that sort of thing. It could just be one class name if it's in the global class scope. So here we have a mock object that will now pass that type hint. But we don't have to stop there. It doesn't have to be an actual class. It could be an abstract class. It can be an interface. And we can also give it a comma-separated list of interfaces. And so what this will do, especially these last two, these are important because sometimes you really don't need to mock a concrete class. You just want your mock object to adhere to an interface that you need to pass in. Sometimes our type hints are all about interfaces. As long as it matches an interface, it will accept it. Well, here we can type hint the mock object as an interface. We don't have to mock all the other methods that are on that interface, and we can pass it in and use it as our mock object. This is important too because now it will implement all of these interfaces. So if you've got a mock object that needs to go into multiple places, but all of them are type hinted for different interfaces, we were able to give it a comma-separated list of all the interfaces you want it to adhere to. So the basic form of mocking with Mockery looks like this. We either give it a name or a fully qualified class name, or we can leave it empty and have an unnamed mock. We pass it an array of key value pairs. And the key, as I said earlier, is the method to call. The value is the method to return. This is, in general, the simplest pattern you'll follow. This is what you'll probably need for a lot of stuff when you're mocking things. And it's quite succinct. However, I'm jumping ahead of myself. So Mockery allows you to define a name or unnamed mock object, naming all of its methods and return values. They can be type hinted using class, abstract class, or an interface. And by default, any method that's not defined will result in a bad method call exception. So if you create a mock object and then you pass it into a class or a method, and that method internally calls a method that you didn't define on the mock object, you'll get a bad method call exception. But you can also call should ignore missing on the mock object, and that will just make any method call to the mock object return null. So you might want to do that in some test cases where you really don't care about the return value of any of the methods that are on that mock object, so you just want them all to return null possibly. All right, we've already shown simple mock expectations by defining a method name and its return value, but sometimes you need to specify a lot more. Sometimes things aren't so simple and you need more specific expectations of the mock object. Well, Mockery allows you to do this. Earlier we defined our service mock like this. You saw the should receive method, and we said should receive read temp times 3 and return 10, 12, 14. We could have also defined it just like this, where I showed you earlier, where we're just giving it the name of the fully qualified class and an array of key value pairs. In this case, every single time we call read temp, it will return 10. And we can call it as many times as we want. And it will always return 10 every time we call it. But then we couldn't test the expectation that it's called 3 times. And so if you remember our code, our temperature class in the average method, we have a loop in which we call read temp 3 times. And it's possible that each call would return maybe a different value. In order to really test this, we need to specify that our mock needs to be called exactly 3 times. And that way, if it got called more than 3 times or less than 3 times, we would get an error in our testing. So this test of the loop that you've specified here is working correctly. So as you'll recall, we've asserted that the return value of read temp has to be called 3 times. The return value of average method was 12, since it averages these 3 temperatures. So we can set up an expectation where and return, as I mentioned earlier, is a sequence. But we can do this without the times modifier, right? We can just say, the first time you call it, return this value. The second time, third time, fourth time, and so forth. You can just give it as many arguments as you want, and each time it gets called, it will return that next one in succession, right, down the line. Using the with expectation, you can define the exact method parameters that the method should receive and the value to return for those method parameters. So in this case, we're saying that the foo mock object should receive a method call called method call, because I'm not very creative. And it should have these values as arguments, method arg values. These are just strings we pass in as 3 arguments. And if it receives these 3, then we'll return true. But here's the same method call, maybe in the same test, with different argument values. And if it receives these 3, it should return false. And then also, same exact method call again, with no arguments, we'll return 1, 2, 3. This is what that looks like in a test. So assert false, we're calling method call with these argument values, so it should return false. And with these argument values, it should return true. And with these argument values, the same method call returns 1, 2, 3. Of course, I'm asserting these for my test on a mock object itself. But the idea, though, is you're taking this mock and passing it into whatever unit you're testing. And from within that, if that unit is giving it known argument parameters, you're able to differ what your mocked method is returning based on those argument inputs. So we've seen how and return may be used to return a specific value or multiple values in a sequence, or depending on what arguments you pass into it. What if you, maybe within your unit, don't know exactly what parameters are going to be passed into it, but you want to capture the arguments that are passed in and then do something with them? You can use a closure and the and return using method. So in this case, I'm creating a user mock that might have a method on it called getFriendById. And when you call the getFriendById mocked method, it's going to run this closure. It's going to pass any value you've given that into the closure. So here we have $ID. And then it's going to do something special with that. In my test here, I'm just showing that maybe just for the sake of example, you've got a list of stubs, like in JSON form, that you're going to grab and then return as an object, as like a standard object, standard class object. So that's what we're doing here. We're taking that ID that our method passed in here, and we're going to grab some JSON file, decode it, and return that. So now when I call user getFriendById and I give it an ID of 1, maybe we've got a file on disk somewhere that it grabs, and then now we can say friend name, and maybe it has Jane Doe in it. So you can think about this where maybe like this method needs to do some database handling or something, and instead of calling the database, you have it grab records that you know, static records from a file, and populate a record set to return, for example, based on whatever inputs it received. Oh, you can also, I got confused here for a minute, sorry. You can also set an expectation that an exception will be thrown when you call a mocked method. So in this case, let's say that we want readTemp to throw an exception. And we want that exception that it throws to be runtime exception, and the message is an error occurred. So we want it to happen when we call readTemp. We're not going to call readTemp from our test though. We're going to call average. Average will call readTemp, throw the exception, and then we're using PHP units annotations here in order to say that we have an expected exception, a runtime exception, and the expected exception message is an error occurred. So expectations on a mocked method affect its behavior depending on inputs and the number of times called. We've covered times with no args, and return using, and throw, but Mockery provides a lot more, and it even provides some convenience methods.
Do you know offhand if the built-in PHP unit mocking framework does the and return using thing with the closure?
I believe it does.
Okay.
It's just like a little more kind of verbose, yeah.
Okay.
I mean, I've used PHP unit mocking for a long time, and I had no real problems using it myself, but a lot of people love just kind of how Mockery flows, and I've started using Mockery and I really enjoy it as well. So both of them have their strengths and weaknesses, I think. I don't know if Mockery has any weaknesses in the same vein that PHP unit does, as in like PHP unit doesn't let you test static methods anymore, or final classes, but Mockery does. Anyway, there's a lot more that it provides, and there's some helpful convenience things too. Like you could say and return and put in a value of null, or it has a method called and return null. So they do the same exact thing. It's just, whichever one you want to use. Okay, earlier I mentioned that methods not defined will result in a bad method call exception, unless you tell Mockery to ignore those missing methods. What if you want to mock certain methods on a concrete class or an abstract class, but not all of them? What if you want the methods not mocked to retain their original behavior? Well, then you can create a partial mock. So let's examine this. This was our first example. Let's just consider that the service class has other methods on it. And when you're running your test, you want those methods to behave as they normally do. But maybe the read temp method does something that you don't want it to do during the test. So you want only it to be mocked. In this case, we can specify when we're setting up our mock, here's our fully qualified name to the class, and then in square brackets, we're going to say read temp. That's the method we want to mock. We can also we can also specify other methods as a common separated list between those square brackets. So if there's other methods on it, we can just say read temp, other method, and so forth. And then we would continue our mocking just the same way we did before with the should receive statements. We can also pass the array to it as the second parameter with those methods as well. Consider though that this is kind of important because maybe you want a full real object that's the service object with 1 or 2 or 3 mocked methods on it. And as a result, you might have to pass some arguments to its constructor. So we can't call the new keyword to create a new service object. Instead, to do that, we can just pass the constructor arguments as an array as the second parameter here as well. So as long as it's not a key value pair array, it will interpret that as being constructor arguments. If it's key value pairs, it will interpret it as method return value. Oh.
Sorry. Can you do both? Can you pass in constructor args and?
I think it will let you do both, and then the constructor args will become the third parameter. It just kind of like intelligently figures out what you mean.
Wow. Okay.
I think. I'd have to look that up. Okay, so classes and methods marked final are a touchy subject, but Mockery can help us test those classes and methods. So we talked about partial mocks a minute ago. We'll talk a little, I'm jumping ahead of myself, so let me not jump ahead. Let's consider this example where we have a UUID class. Let's assume that Ramsey Talks UUID is our class and it is a final class. I hope everyone knows what a final class is. It's when you create a class, it's like class UUID, but in front of the class name you put the word final. What that means is you cannot create children of that class, so I can't extend from that class anymore. It also means I can't mock it. Mock object frameworks won't work with that. So like PHP unit, it's just gonna die from. I don't know exactly what error message you'll get, but you'll get an error message about being unable to mock a final class. In this case, we're saying we're trying to mock it, right? We're going to try to mock this final class. We're going to say that the UUID4 method on it should receive, or we should receive a call to UUID4, and then we'll return the static known UUID that I've got here. Well, when we try to do this, Mockery, if we're using Mockery, we'll get this nice message. Mockery exception, and it will tell us exactly what we need to do. And here's the key. Classes marked final can be passed into Mockery as instantiated objects to create a partial mock. So let's see what that looks like. Here, we instantiate an object of the final class, and then we pass that in to mock it. This is called a proxied partial mock. So we have an instance of the object, we pass it in to mock it, and now we can actually capture and override the behavior of methods on it, even if those methods are marked final too. The downside of this approach, though, is that this mocked object doesn't inherit its class type. So it can't be used, like if you're using type hinting and trying to pass this object in type hinted, you can't use it. And so someone pointed out in an earlier talk that if you can't type in it, then effectively, why not just do an unnamed mock with the methods on it? And that might be true, so maybe that's an option. But if you do an unnamed mock and you want the behavior of all the other methods to remain the same, then you're gonna have to mock every single method. So in this case, like the behavior of all the other methods on the UUID class will work. We're just mocking one of those methods, or we could mock multiple if we wanted. Mocking public properties is easy to do, very simple. This one, really, technically, I don't even know if you'd call this mocking it. I'm just creating a mock object, and I can set any public property I want on it. However, the thing you might often want to do is if a method is called on a mock object, you might want that method to set a public property. And so in this case, we're saying that this should receive a call to method call, and when it does, we'll set a property on it with the value 1, 2, 3, and then the method call will return true. So in this case, we can test that by saying assert true on method call, so we call it, and then assert that the public property equals 1, 2, 3, and it does. So this might be useful within some unit that you're testing because maybe you call a method and then something else on that mock object, and maybe you're doing a partial mock, for example, expects that public property to exist and have a certain value. So in this case, you're able to set that value. We can also mock fluent interfaces. So you might be familiar with a fluent interface that looks something like this, or sometimes it's called a Demeter chain. It's this idea where like I call a method, it returns an object, then I call a method on that object that it returned, then I call a method on that object. We can stack these up and go on forever if we want. But this last method, cucks, should return, and these are metasyntactic, all metasyntactic variables by the way. This should return whatever we want to have in $ result. And then we want to use that result. So how do we test that? Well, Mockery lets us do that really easily. In should receive, we set up our chain. We don't have the parentheses, but we do have the full chain. And this is basically saying that when it gets to the end of the chain, we want it to return done. So now we can instantiate bar, call bar, get something, pass it our mock, and it's going to call that whole chain, return done, and we want to assert that the string we got back here is now we're done. Not really difficult, but there's not a lot of documentation around it that shows how to do that. All right, I'm going to talk about some controversial things. Mocking static methods. Whether or not you should use static methods is a subject of intense debate. And PHP Unit used to support mocking static methods, but they've chosen not to allow that anymore in the newer versions. But if we're working with legacy code, sometimes it's unavoidable. We can refactor that legacy code to use proper dependency injection, but sometimes we can't do that. Maybe we just don't have the time, or it's just not worth the effort. Maybe it's a tiny little change we need to make. We don't have the time to go refactor the whole code base. So Mockery allows us to test static method, or to mock static methods for the purposes of our tests in the event that we have to use them. So let's think about something like this. We've probably all written code like this. I believe Adam showed similar code to this in his refactoring talk yesterday, if you attended that. In this case, we're using a static method on this address class to get an address by ID from within the user class. So we'll call getAddress, and that's going to return an address object. We're calling a static method on address. The reason this is so difficult to test is because address cannot be replaced. It's a class, and in this case, it's almost like a constant, right? We can't replace that word address from within a test. It's just unreplaceable, like there's nothing to pass it in. And if we're going to test this, we're afraid that something could change in the database. get by ID. Maybe it talks to a database. Maybe it talks to a service. Maybe it does something and has a side effect that we don't want to happen when we're testing it. So we need to replace it. Mockery can help us do this. All right. In this case, we're going to mock the address class using a special prefix called alias. Here's the magic of Mockery. What it does is it creates a class in the scope of the test and injects it into the test and then uses that instead of loading your real class. So in a partial mock, it's going to load the real class, right, and replace methods on it. In this case, the real class is not loading at all. It's going to inject its own class with this name into this test and put this method on it. And so alias is going to allow us to do this, and then when we call get address, so it's going to return a new address. We don't really care what's on this object. We just want it to be of that type. And then we're going to test that it is an instance of address. All right. What is going on here is if we were to run this without that comment at the top that you saw on the last slide, we would get an error that looks like this. Could not load mock Ramsey talks address, class already exists. This will happen if you're using auto-loading and it's already been loaded in a previous test. That means that the class is already in scope. Your real class is already there. And Mockery cannot create another class with the same name, or PHP can't create another class with the same name. And that's what it's telling you right here. It's trying to create another class with the same name. Additionally, if you're not using auto-loading and you're using requires to load your classes, this is always going to happen. You really can't get around this. So you can't use this functionality if you're not using auto-loading. But if you are using auto-loading, what's going to happen in an auto-loading situation is if the class does not yet exist in scope, when it tries to use it, it will use the autoloader to load the class. Mockery gets around that if you run your test in isolation by using these PHP unit annotations, run in separate process, and preserve global state disabled. You have to use both of them. If you use these on your test that you need to be isolated, Mockery creates this class first, so that if we hit this, or if we run get address and it uses that, it tries to access that address class, it is already in scope. So your autoloader says, oh, that class is already there. I'm going to use the one that's already there. It doesn't try to load it at that point because it's already in scope. Is that making sense? So that's it's all magical, but in my mind, it's a little magical, but it makes sense what's going on here. It's just essentially replacing your class address with its own class so that it can mock the static method. Same thing happens for hard dependencies. So sometimes you have hard dependencies in your code, and these are just as difficult to test as a static method. But the answer is the same, right? Use dependency injection when you can. However, as I mentioned on static methods, sometimes we just can't do that. We've got extenuating circumstances that mean we need to test this code as it is. And Mockery allows us to do that. What do I mean by hard dependencies? Well, it's the same as that static method almost. But in this case, we're creating we're using the new keyword to create an instance of address. Again, address is a class that we just can't replace at this point. It's got to load it from somewhere, and the autoloader will often just say, oh, you've got an address class and Ramsey talks address, so I'm going to load that one. The solution, though, is the same, with a slight difference. In this case, in the last case, we saw the keyword, the prefix alias. In this case, we're going to use overload. And what this tells Mockery is that when we create this class, anytime we use the new keyword to instantiate it, the new instance of it will be a mock instance, or an instance mock, and it will inherit all the mock methods that we've defined for address. Now in this example, I'm not mocking any methods on address. But if I were to mock a bunch of methods on address, in our running code, whenever we say new address, that instance now has all those mocked methods on it. And as with alias, we also need to run this in a separate process for the same exact reasons. We don't want it loaded yet. And this is also why when you need to run Mockery close in your teardown method, because if we run this, it creates this class in memory. The next test that runs will already, if it's using address, will already have an address class in memory. But it might not be the Mockery one we want it to have. We might want it to auto-load. So we need to tear down and close Mockery up so that it can clean all that out. All right, so let's wrap up. In wrapping up, I do want to mention one more thing that's important. Sometimes you need to tell whether or not your object is a mock object. And Mockery allows us to do that because they're all Mockery mock objects are instances of mock interface. So sometimes in your test, or maybe even in some of your code somewhere, you need to determine whether or not that's an instance of a mock object. I actually do use this in production code. And there's a real reason for it. I am using mock objects in production code because, let's see if I can explain this because I didn't create a slide for it. It just popped in my head. The reason I'm doing that is I am showing a user dummy data to show them what an email message body will look like. Just a template. I'm not letting them fill in the details, but I'm letting them put a subject and an image and stuff in place, and then on one side of the screen it's refreshing and showing them what that email looks like. Well, I don't want to use the actual objects because they might have some side effects on them. Instead, I'm mocking them, and then in that code I want to look at them and make sure that what I've got is a mock versus a real one, because we are also using the same code with some of the real objects. It's really weird, and maybe I shouldn't be doing it, but I am. So it's possible. Everything's got a reason for it, right? All right. So let's review. Mock objects are used to replace real objects in tests. Mockery lets us create some dumb objects, and by dumb I mean the unnamed mocks or just the named mocks that aren't tied to a specific concrete class. You can also create a mock inherited from a class or from an abstract class, or that just implements an interface. We saw how to use proxy partial mocks to mock final classes and methods, and we mocked public properties and fluent interfaces. And then lastly, we created an alias mock to mock a static method, and an overloaded mock to instantiate mocks with a new keyword. Any questions?
I've got one.
No?
So you mentioned you can do the public interfaces, and in your example, they didn't have any parameters. I just want to make sure that it can do the fluid interfaces. You can do the fluid setters the same way, right?
You mean fluid interfaces with parameters passed into them?
Yes.
I am going to assume yes, but I did not test. I have not used that, and so I have not tested it. Again, the documentation for fluent interfaces is one paragraph that says, yes, you can do this. So really, all of my code, by the way, I did test to make sure that it worked. But I would have to just try it out and see what happens. I guess in where you would want to really make sure that works is if you're expecting certain arguments passed in, and you're going to return values based on the arguments passed in. You might be able to test the last item in the chain, or figure out what method argument should be passed to that, but I don't know about the other ones in the middle. So I'm sorry I can't fully answer it, but we'll figure that out maybe.
In regards to the overload functionality, what if you need to overload multiple objects or multiple instances of the same object?
What if you need to overload multiple instances of the same object? Within the same test that's running, you would not be able to. You'd only be able to, because because it's creating that class in the scope of that test. And so if you're trying to create a second one that overloads, it wouldn't be able to inject a new class in. What you'd probably end up doing is, because the only thing I can think of, and maybe you can give a better example of what you're thinking, is maybe you've got multiple, a method on it that you want to call multiple times, and sometimes you want it to return different values. So you might use a with expectation to be able to do that on that one mocked object, or one mocked instance object, right?
Well, I guess I work in some pretty legacy code, and so I'm just trying to think how I might be able to use this in that code, and that we have a fair amount of what I refer to as data objects that don't really have any functions. So the reason why I would be mocking them would be I want them to have specific data in them, but it would be multiple instances of that same object.
Oh, so you're using a new keyword within your code that you're testing. Yeah, I see what you're saying.
Like I said, legacy code.
Right. I don't know. Well, we could look at that and see, like later, like after the talk, maybe we can take a look at it and just try something. I don't know. I'll be around, so I'm happy to like run some sample tests and figure it out.
Yeah, I mean, I can play with it too.
Okay.
I was just wondering.
I don't know off the top of my head.
Okay.
I don't think you would be able to do quite that, but you might be able to figure out a way to do something that'll help. Any other questions? Actually, one way you might be able to do it is using, well, I don't know, we can talk afterwards. All right, well, thank you very much. My slides are up on Joined In. Please rate the talk. Give me feedback so I can make this talk better. Thanks.